Good deal. So this is going to be using Anton's equation, both linearly and non-linearly regress data that we extract. So we're going to use wget to obtain the data from the web file, but the link that we use for wget has to be a raw link. And I have already, go get that real quick. All right. Good deal. So we'll test that to make sure it goes. Excellent. All righty. So now we want to import all the systems and functions that we need to use. So numpy, np, import pandas as PD, and from scipy optimize import minimize. We're going to need that one. It's a very useful point. So let's start by making, we're also going to need plots, be able to make plots. So from poly subplots and import subplots. We're gonna import plotly as, and let's set that to the Dart template because that does actually just look better. Oops, there. All right. Sure we haven't made any mistakes yet? We did. All right. SciPy optimize, import minimize from SCI. I just haven't. Okay. SCI optimize, excellent. All right. So now we need to set the data, set the needed information from the water vapor pressure to make the delimiter, and we're going to set the needed information from water pressure, and then we have to make the delimiter a comma so we can utilize that information effectively. So we're going to load text, and the actual name is, I think, water vapor pressure .csv. Okay. .csv. Good deal. And we gotta set the delimiter to a comma. All right, let's give it a go. No errors yet. Beautiful. All right, we want to sort the data, which is the first column. So we're going to make capital T, temperature, is going to be equal to for the data, and it's going to be the first column. Excellent. Sure, excellent. Now we need to find the log base 10 of the second column, because I mean, I guess I could pull out the data, but I don't think it'll come up at this screen. Then I would have to, no. So, because my last one was over an hour long, so I'm gonna try to make this quick, relatively speaking. Log 10 of the data. in the second column. So 1. Good deal. And this is the non-linear. We're going to do non-linear first. So let's make our plot, our first plot here. So make a figure. Subplot. We're gonna scatter plot, where x is going to be the temperature and y is going to be the log. No, we don't need quotes on that yet, actually. It's markers. Name, it's going to be data. Doesn't really matter. Good deal. No. Excellent. All right, and we're going to make sure the size is correct. Let's make it what should we do? You know what? Let's make it nice and even. Good deal. All right, let's see. Excellent. So that is our first figure for nonlinear regression. So to do the linear regression, we're going to, no wait. Okay, now we want to make a design matrix. So we already have the log p, but we need to invert it so that we can use it effectively. So x is going to be equal to numpy dot, where the first is temperature, then negative log p. And we can insert our equation now. Let's see, actually, no, wait. Let's fit it. Give me a second. Okay, so we'll fit it to a vector, and then we'll use the inverse transpose of the design matrix by the design matrix temperature and then log. Yeah. So because we have the equation, B is equal to A times C minus D, and we're going to implement that. But first, we need to get these values. Is equal to linear algebra. Nice. Inverse. Excellent. X dot T. Nope, capital T. X. And then at capital X, yep, because I'm dumb. At x dot T. T times the log P. Good deal. And then now that we've gotten those values. Let's make sure. Let's make sure that all this is correct. So we made a mistake. I don't think that's the problem. Oh, okay. Let's give that a go. Yes, excellent. So as we can see here, we pulled and then calculated the correct values for those, which is excellent. So to prevent the, let's see. Wait, we're supposed to have a line here. Why don't we have a line? Did I forget something? Here, I'm going to pause and make sure that I'm not wasting time. We're not supposed to have a line here. I'm literally doing the one with the line in it now. All right, so let's. All right, so we don't want our plot to be segmenty or choppy. So this will prevent that. But in our new figure with the line big dot, no, scatter. Yep. X is equal to t plot. Y is equal to a minus b divided by t equal to plot plus c. All right. And the lines. Lines. And we're going to call this one linear because it is still linear regression. It's quotes because we're not dumb people. Good deal. All right, let's give it a go. Yeah, we made a mistake there. What mistakes? So, NumPy has no attribute line spec. Yeah, I bet it doesn't. Linear space. LIN. Temp is not defined. Oh, I think we use T. Anyway. Good deal. All right. Can't assign a function to a cell. So I'm going to pause so I can think, and then I will re-record before I do anything. All right. I think I literally just forgot that. No. All right. Right back. And okay, now that should be good. Yes, excellent. We have a nice smooth line. The reason we have a smooth line because of this right here creates a minimum there, so we don't get that big line block here. We don't have a lot of points there. So this is the linear regression. But now we want to do nonlinear regression. So nope, not text. We want to create a function for the sum squared error, and we want to unpack the parameters. So let's define sum squared error. Let's do what x? No, we don't want to do x. C. Nope, we don't want to do C there. V. There we go. It's fine. So A, B, B, and C equal V. We got a sum deviation, which is A minus B divided by T plus C, but we have to square, so the negative deviations are factored in evenly with the rest of them. So that's with the positive eyes. I lost my train of thought. Okay, no, we're good, we're good. Nope. So sum, we're going to do our little equation. Temperature. P squared. All right. Excellent. But we still need to minimize the sum squared error. So good deal. And boom, we have minimized it, but we only want the values here. So we want to add a dot x, so it only pulls the dot x. If we wanted anything else, I think we could just add a dot like fun or whatever, but we don't. We want the x value. So yep, and it will pull just that right there. So because this is linear, this is nonlinear, we want to now set a nonlinear, a non-linear, b nonlinear, and c non equal to those three x values. Good deal, and it is done. So now we need to graph them. So we're going to get a graph where we want to plot x is t and y is going to be the equation from before, but now we're going to use the nonlinear values that we pulled. So scatter x is going to be t. Yep, t plot. Y is going to be a nonlinear minus b, capital B. No, I don't want that. Why are you doing that? Don't do that. No. Okay, I don't think you can see that anyway. It's just annoying to me. So I'm going to ignore it and continue. And we're going to divide that by t plus c. Excellent. All right. And what am I missing here? Why do I have an equal sign here? missing? What we're going to utilize. And we're going to call it nonlinear. All right, bring on the errors. Actually, no errors. Excellent. And there we have it. Okay. All right. I lost my train of thought there for a second. So we have both linear and nonlinear regression. And nonlinear regression is usually used to generate a curve to fit some exact data. The sum squares is used to determine like the preciseness, the ability of the data to the ability. The sum squares is used to determine how accurate a regression model can be, which is usually found by finding the difference between the average and every single individual point. Now, nonlinear regressions are used because they can be relevant, there we go, to a lot of different kinds of functions. And the purpose, my internet cut out there for a second, I apologize. But I was talking about linear versus nonlinear and why we minimize it. So by minimizing the sum square error, you can get a better and more consistent estimation of the model, of your parameter model by the Gaussian mathematics. Boom. But there we have it. Excellent. Hope you have a great day.